We have all seen SNOP cycles that run on time series heuristics. They are great for high level capacity checks, but they are mathematically lazy. They don't respect the pegging of a specific sales order to a specific batch. In real world, your shop floor doesn't care about your monthly consensus plan. They care about the confirmed delivery date on a sales order. Today, we are talking about the transition from time series to order-based planning. We are diving into the technical plumbing of SAP IBP response and supply and how to synchronize it with EPPDS. I am Rahul Sahasranaman and this is Zero Bias. The disconnect between SNOP and SNOE usually happens at the data model level. SNOP lives in the time series and SNOE lives in orders. If your SNOE process is just a weekly version of your SNOP, you're missing the point. SNOE is where we introduce, for example, finite scheduling. It is where we move from aggregated capacity to individual work center constraints. If your IBP supply and response data model isn't talking to your S4 data model, your SNOE is just a PowerPoint exercise. Let me give you an example. There is this company X who had a weekly meeting set up to discuss about the issues they were facing in that particular week from supply standpoint, namely port congestions, line shutdowns, etc. They would come up with mitigation plans on the fly based on their experience and some Excel exercise, of course. Interestingly, they called it SNOE meeting as they were managing the operations level nuances on a weekly basis. Yes, that can be arguable, but the approach to such meetings and the solutioning of the problems at hand is what we will be discussing today. Here is the technical zero bias truth. Many companies struggle because they don't use the gatekeeper logic. They send every forecast change to execution. A technical SNOE process uses constrained forecast. You run the IBP constraint plan, it sees the capacity constraints, and it only confirms the quantities that are actually feasible. You aren't pushing wishful thinking down to the plant, you're pushing a feasible supply plan. Let's take an example to understand this better. Imagine you are a tier 1 supplier for automotive braking systems. Your SNOP plan tells you that you have a consensus forecast of 50,000 units for the month of October, for example. Suddenly, on a Tuesday morning in late September, a major OEM sends an EDI signal. They don't want 50,000 anymore, but they want 75,000. And they want it now. Without a gatekeeper logic, that 25,000 unit spike drops straight into the execution system. The S4 HANA system sees this as a new requirement and starts exploding MRP. It creates multiple secondary plant orders for all the parts that is needed. The result is the shop floor goes into a panic. They start robbing parts from other orders to satisfy the loudest customer. You have just introduced unconstrained chaos in your factory based on the request you have not even vetted yet. This is where SAP IBP Response and Supply acts as the gatekeeper. The 25,000 unit spike hits IBP first, not the shop floor. It sits in the unconstrained demand bucket. You run a constraint plan, and then the system looks at all your constraints and identifies more evenly what about the 25,000 units that can actually be produced. It then identifies that only 10,000 can be produced. This is the 10,000 which is the constraint forecast that is sent to S4 and EPPDS. The gatekeeper logic is the difference between telling your production manager, hey, the customer wants 75,000, good luck. Instead, we are saying we have mathematically verified and 60,000 is something that is possible. So here is a feasible plan for exactly 60,000 to make it available for the customer. Now let's look into the triple thread. When IBP response calculates a planned order, it is still relatively bucketed, right? This is where synchronized planning with EPPDS changes the game. The planned order that is sent to S4, where EPPDS takes over for detailed scheduling, it looks at the setup matrix and maybe even more. It knows that switching from blue to red, for example, requires a 2-hour changeover. It optimizes the sequence on the work center, and here is the magic. It sends the calculated start and end date back to IBP. Your IBP analytics is now showing the actual machine level reality. But this is all a real situation or ideal situation. But what happens when a machine goes down? In EPPDS, you either trigger a rescheduling manually or by optimizer, for example. The TS optimizer finds a new sequence in case we are running the optimizer, and because of this synchronized link, this change ripples back to IBP. The IBP planner sees an alert because a sales order is now delayed because of this downtime. Isn't a weekly planning conversation, it's a systematic handshake. You're moving from manual adjustment to digital synchronization. In 2026, the agile supply chain is built on order-based planning and synchronized execution. By linking IBP response to EPPDS, you're turning your supply chain into a high-frequency execution engine. You are making your decisions not based on optimism, but really optimizer results. Here is your zero bias challenge for the week. Go into your IBP planning profile and look at your demand prioritization settings. Are they still aligned with your current business reality, or are they still default? Pick one work center in BPDS, the plan versus actual start times for 48 hours, for example. If they are off by more than 10%, your synchronization is broken. Fix the plan. I'm Rahul Sasnavan. Stop guessing, start synchronizing. Start.